First, we go to the introduction to the concept of fundamental of logic. Logic is the essence of reasoning. Logic is used to determine whether a statement is true or false, but not both. Logical rules are common in control systems to define how they should operate. And then we go to the logical connective. There is 5 logical connective. First, we go to the negation. The negation operator denoted by the symbol not take the truth value of the original statement, then output the exact opposite of its truth value. So we can see through the negation truth table, if P is true, the not P is false. If P is false, the not P is true. Then we go to the conjunction. A conjunction is a type of compound statement that is comprised of two propositions joined by the AND operator. So we can see through the conjunction truth table, if P is true, the Q is true, then the answer P and Q is true. If P is true, Q is false, the answer will be false. If P is false, Q is true, the answer will be false. And the last one, if P is false, Q is false, the answer will be false. Then we go to the disjunction. A disjunction is a kind of compound statement that is composed of two simple statements formed by joining the statement with the OR operator. So you can see through disjunction truth table, if P is true, Q is true, the answer will be true. If P is true, Q is false, the answer will be true. If P is false, Q is true, the answer will be true. If P is false, Q is false, the answer will be false. Then we go to the implication. An implication, also known as conditional statement, is a type of compound statement that is formed by joining two simple statements with the logical implication connective or operator. We can see through the implication truth table, if P is true, Q is true, the answer will be true. If P is true, Q is false, the answer will be false. If P is false, Q is true, the answer will be true. Then if P is false, Q is false, then the answer will be true. Then we go to the last one, is biconditional. A biconditional is a type of compound statement that is formed by joining two simple statements with the biconditional operator. We can see through the biconditional truth table. The biconditional is known as double implication. If P is true, Q is true, then the answer will be true. If P is true, Q is false, the answer will be false. If P is false, Q is true, the answer will be false. Then the last one is, if P is false, Q is false, then the answer will be true. Next, we go to the law of logic. The definition law of logic is using the concept of logical equivalence, tautology, and contradiction. The following is the list of rules for the algebra of proposition. For example, there is a logical law corresponding to the associative law of addition A plus B plus C equal to A plus B plus C. In fact, associativity of both conjunction and disjunction are among the law of logic. Next, we go to the type of law of logic. There is 12 law of logic. The first one is double negation law. We can see not P is will be P. Then we go to the De Morgan's law. Not P and Q will be not P or not Q. And then if not P or not Q will be not P and not Q. Then we go to the commutative law. If P and Q will be Q and P. If P or Q will be Q or P. Then we go to the associative law. P and Q and R will be P and Q and R, but the Q and R in the bracket. So in the bracket, P or Q or R will be P and Q or R, but the Q or R is in the bracket. Next, we go to distributive law. In the bracket, P and Q or R, then the answer will be in the bracket P or R and in the bracket Q or R. Same goes to the P or Q in bracket or R, and the answer will be in the bracket P and R or in the bracket Q and R. Then we go to the idempotent law. If P and P, the answer will be P. If P or P, the answer will be P. Next, we go to the identity law. If P and T, the answer will be P. If P or F, the answer will be P. Then we go to dominance law. If P or T, the answer will be T. If P and F, the answer will be F. So next we go to the inverse law. If P and not P, the answer will be F. If P or not P, the answer will be true. The next one is absorption law. In the bracket P and Q or P, the answer will be P. And then in the bracket P or Q and P, the answer will be P. Next, we go to the implication. P go through to the Q, the answer will be not P or Q. And then the last one is biconditional. P, Q, the answer will be, then in the bracket P go through to the Q and Q in the bracket Q go through to the P.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Fikmal bin Yusni, and today I'm going to present to you our question that we already choose. So the first question, simplify in the bracket P or Q and not in the bracket not P and Q using the laws of logic. So the first step that we choose is the Morgan's laws. So it will become in the bracket P or Q and in the bracket not P or not Q. So the next step that we choose, double negation laws. It will become in the bracket P or Q and in the bracket P or not Q. So the next step, distributive laws. It will become P or in the bracket P or not Q. The next step, inverse laws. P or F, and the last step, identity laws, and the final answer is P. So we go to the next question. The question, simplify in the bracket if A then B and in the bracket if A then not B using the laws of logic. So the first step that we use is implication. It will become in the bracket not A or B and in the bracket not A or not B. So the next step we use distributive laws. It will become not A or in the bracket B and not B. The next step, inverse laws. It will become not A or F, and the last one, identity laws, and it will become not A.
Okay, now we move to switching network. So for the definition, switching network is a network made up of wires and switches connecting two terminals, T1 and T2, in such a network. Okay, each switch is either open or in bracket we put as F. F is false and it is equal to no current flow. Okay, the second one is closed. So close in bracket we put as T. So T means true. So T is equals to current flow. Okay, after that, an open switch will not permit the current to flow, while a closed switch will permit current to flow. Now we move to type of network, which is the first one is a network with one switch. Okay, so as you guys can see, there is just a one switch which is P, okay, between the first terminal and the second terminal. Okay, for this case, we can't do anything because there is just one switch, so we cannot compare with others. Okay. Okay, for the second type of network is a parallel network, which is, as you guys can see, P and Q is parallel because after the first terminal, the wires is branched into two sides for make sure that P and Q is a parallel. Okay, so if you guys facing this problem, you guys can do it as a disjunction statement, or also known as OR statement. Okay, so for this case, we can do it as P is disjunction with Q. Okay, so for the last type of network is a series network. As you guys can see, there is one line that connect between two terminal, which is the first terminal and the second terminal. Okay, and then from this line, this one line, there is two switch, which is P and Q. Okay, so if you guys facing this problem, you guys can do it as a conjunction statement, or we also known as AND statement, but it sometimes can be but statement. Okay, so P is conjunction with Q. Now let's go to the example question and problem statement to make sure you guys can understand about this topic.
And now I'm going to present to you the question that we choose for switching network. So this is the diagram of the question, and the question is in the bracket P and Q, or in the bracket Q and R. We solve this question by using the laws, and final answer is in the bracket P or R and Q. So this is the answer. The P and R is in a parallel network and the Q in a series network. So this is the second question that we choose. This is the diagram, and the question is in the bracket P and in the bracket R, or not Q or Q, or in a bracket R, or not T or not T and not Q. So the final answer is P, or in a bracket R, or not T and not Q. So this is the diagram for the final answer. P is parallel with the R, or not T and not Q. And next, R is parallel with the not T, and the R and not T is in a series network with the not Q.
Okay, for a summary from this topic, learning about logic helps us think clearly, like following rules to make good sense. Imagine logic as a guide for our tools. Switching networks like traffic directors for computer information. They decide how data move between devices, either in a straight path or in a small packages. Knowing this is important for building a smart and reliable communication system. In a nutshell, logic and switching networks team up to create smart systems in our connected world. Logic guides our thinking, and switching network make sure information goes where it should, like having a good map and traffic rules for our digital world. Okay, so I think that's all from us. Thank you for paying attention, and Assalamualaikum warahmatullahi wabarakatuh.